Hello, I'm Glenn Murphy with Burroughs Wellcome Science Explorers, and today I'm at the University of North Carolina, Chapel Hill, where I'm talking with Dr. Laura Miller. Dr. Miller has a pretty interesting job, and one you've probably never even heard of. She's a mathematical biologist. So let's go talk to Dr. Miller and see what she's been up to. Dr. Miller, thank you for joining us.
Yes, thanks for coming to University of North Carolina.
So first up, what exactly is mathematical biology? I mean, a mathematician works with numbers and a biologist studies living things. So how or why do you do both?
There's a new emergence of mathematics and biology that's been happening starting this century that's really picking up a lot of momentum. It's basically how can you use mathematics to help answer complicated questions in biology.
So did you always want to do this kind of thing? I mean, not just be a scientist, but be a mathematical biologist. I mean, when you were in high school, did you think to yourself, after I graduate, I'm going to work with jellyfish and insects and zap them with laser beams and things?
So I couldn't really decide what I wanted to do. I thought about mechanical engineering, mathematics, physics, biology. I started as a math major and then switched to biology. Went to grad school in biology, but then decided I'd like to do more math. So it was really just trying to combine everything that I like to do in one project.
We're off to the UNC Math Labs, where they use laser beams to create virtual animals. How cool is that? Let's go find out how it works. So we just learned when we were talking before that part of your job involves building virtual jellyfish. So I guess my first question would be why? I mean, what can we do with a virtual jellyfish?
So the nice thing about it is that you can change their size, their shape, the way that they move, only by changing a couple of numbers in a computer. Whereas if you had robots, you'd have to build a new robot for each one of these changes, which would take a lot of time and money.
So how do you go about making one? I mean, how do you build a virtual jellyfish?
So you need equations that describe everything. You need equations for the jellyfish, for the fluid the jellyfish is in, for any animals that they're trying to capture. And then you put it all in a computer, simulate it, and visualize it. And then you need to compare it to reality. So we take actual jellyfish, like these guys right here, and we shine a laser sheet over them to illuminate some particles to see what the fluid is doing and compare it to the computer.
So what have you found so far?
Well, one of the neatest results is that jellyfish typically swim about one body length every second, unless they get too small, and then they really can't get around using jet propulsion or paddling. So either they can't swim, or if they're that tiny, they have to have a different way of swimming.
And how do they get about when they're that small and they're babies?
So they have a different form, a different larval form, that basically swims with something like a corkscrew that plows, you can think of as drilling through the water at that point.
Wow. Dr. Miller, thank you very much.
Yep, thank you.
That's it for part 2. Join us for part 3, where we'll be finding out how this research could prove handy for soldiers, spies, and the search for alien life. Seriously, spies and aliens, coming right up.